Hi everyone, in this video we are going to be looking at solution to 4 questions. All these questions appeared from the topic from the chapter probability. These questions are presented as part of the sample question paper given by the CBSE Board for the term 1 examination of the academic year 21-22. 4 questions in total we will be looking at. All of these are multiple choice questions, right? 2 fair coins are tossed. What is the probability of getting at the most one head, right? First step what we will do is we will count the total outcomes, right? We will list down all the outcomes and count the total outcomes when 2 fair coins are tossed simultaneously, right? Let us look at that. Total outcomes will be when 2 coins are tossed simultaneously is both the coins could turn out to be heads, one head, one tail, one head, and both of them could be tails. So, talking about a total of 4 outcomes when 2 coins are tossed simultaneously. Now, let us look at the case where we are going to get at the most one head. That is going to be our favorable outcome, right? Favorable outcome is at the most, I will write it as favorable outcome, which is at most one head. What do we mean by at most one head? At most means maximum. So, we are saying that you should have a maximum of one head. That is what it means. One head is the maximum that is permitted. If one head is a maximum that is permitted, essentially we are saying the highest number of heads that you will see is 1, which means you can have 1 or lesser than 1 head, which essentially translates to the number of heads should be less than or equal to 1. It can be equal to 1, it can be less than 1. Less than 1 is having no head at all. So, of these outcomes which all satisfy the condition, this is a case where you have 1 head, this is a case where you have 1 head, and this is a case where you have 0 heads. So, the favorable outcomes for us where we have at the most 1 head, maximum of 1 head, less than or equal to 1 head are basically head tail, tail head and tail tail. So, how many favorable outcomes do we have? We have a total of 3 favorable outcomes. So, required probability of at most 1 head is number of favorable outcomes, which is the outcomes in which you will have a maximum of 1 head divided by the total number of outcomes, which is equal to 4. 3 by 4 is the required answer. I think choice A is the correct answer to this question, right? Let's move on. The crux of this question is basically understanding what does this term at most 1 head means. Once you have got clarity on that, this question is a very straightforward question. Go to the second question. This question is question number 20. Interesting question, very interesting question. A letter of the English alphabet is chosen at random. The English alphabet contains 26 letters, that is known to us. What is the probability that it is a letter of the word mathematics, right? So, we are selecting one letter out of the letters of the English alphabet. The total number of outcomes is the number of ways in which you can select that one letter. So, total outcomes is equal to the number of ways of selecting one letter from 26 letters, which can be done in 26 ways. This actually is going to be the denominator of our answer, right? The total number of ways in which you can select one letter from the letters of the English alphabet. Now, the favorable case is that letter that you selected is a letter found in the word mathematics. So, what we are going to be doing is, we are going to list down all the distinct, unique letters that we find in the word mathematics. If we find a letter appearing a second time, we won't count it, right? Let us just list it down. We are starting with M, A, not repeated, T, not yet, H, E. The next letter is M. M has already been written, so we are not going to count it, right? A already been written, we are not going to count it. T already been written, we are not going to count it. I, C, S. So, what are all the different letters that we find in the word mathematics? M, A, T, H, E, I, C, S. That is how many letters? 2, 4, 6, 8. 8 distinct letters are there. So, if we pick a letter, let us say we put it in a box which comprises all the letters of the English alphabet, what is the probability is that the favorable event is getting a letter which is found in the word mathematics. What are all the letters found in mathematics? These are the 8 letters found in mathematics. If I picked one of these 8 letters, I would have basically got what this question wants me to get. So, the favorable outcome is drawing one of these favorable outcome is drawing one of these 8 letters. So, number of favorable outcomes for us will be equal to 8. So, probability of picking a letter that is found in mathematics is the number of favorable outcomes in the numerator, which is equal to 8, divided by the total number of ways in which a letter can be drawn or picked from a box containing all the letters of the English alphabet. 8 by 26 is the answer, both are even numbers, divide both of them by a 2, so you will have 4 by 13 is the required answer. What answer option? 4 by 13 is answer option A, right? It's a very straightforward question. The only thing that you need to keep in mind is basically that you'll have to count the distinct letters that are found in mathematics, right? Move on from here. The next question is question number 26 as it appeared in the sample paper. A card is drawn from a well-shuffled deck of cards. A well-shuffled deck of cards will have 52 cards in it. What is the probability that the card is neither a king nor a queen? So it should not be a king, it should not be a queen. So let's list down how many cards to start with are kings and queens, right? So any pack of cards, total number of outcomes is drawing one card. Total number of outcomes for us is going to be the number of ways in which we can draw one card from this well shuffled deck, which is going to be equal to 52. That is our denominator. Now the numerator is selecting a card which is neither a king nor a queen. Any pack of cards has got 4 suits, right? Spades, clubs, diamonds and hearts. In each of these suits, you're going to have one king and one queen. There's a king and queen in clubs, king and queen in spades, king and queen in diamonds and king and queen in hearts. So how many kings and queens will we find in any pack of cards? 2 plus 2 plus 2 plus 2, which is equal to 8 of these cards are not what we want. There are 8 cards which are kings or queens. We'll have to select a card which is neither a king nor a queen. So our favorable outcome will essentially, number of favorable outcomes for us will be of the 52, take out these 8. So if we get one of these remaining 44 cards, those cards would neither be queens nor be kings. So probability of getting neither a queen nor a king is actually number of favorable outcomes 44 divided by total number of outcomes, which is equal to 52. Both numbers are divisible by 4. Let's do that. 4 times 11 is 44, 4 times 13 is 52. So 11 upon 13 is the probability of getting a card which is neither a queen nor a king, right? What answer option is this? 11 by 13 is A. Move on to the last question in this video. This is essentially rolling a die. 2 fair dice are rolled simultaneously. When I roll a die once, I'll have 6 outcomes. Roll a die a second time, 6 outcomes. Or roll 2 dice simultaneously. Each of these dice will have 6 outcomes each. So total number of outcomes will be equal to 36. So essentially, we've got the denominator in place at this point. The probability that 5 will come up at least once is what we are talking about. We'll solve this question in 2 ways. One way, let's list down the favorable outcomes, count it, it's not too difficult, and get the answer. Second, let's use the complement of an event and then get the answer. Start with the first method. We know the total number of outcomes for us is equal to total outcomes is equal to, we are rolling 2 dice, 6 times 6, which is equal to a 36. Denominator is done. Favorable outcome is an outcome in which you need to get at least one 5. So let's start with counting the outcomes in which 5 appears as the second in the second die, right? So favorable outcomes for us, favorable outcomes will essentially include 1, 5, 2, 5, 3, 5. Let's start by counting the instance where it appears only in the second die. 5, 5 I'm not counting because it appears as a part of both the dice. So these are the outcomes where 5 appears only in the second die. Now 5 can appear in the first die as well. So we'll count the instances where 5 appears only in the first die. 5, 1, 5, 2, 5, 3, 5, 4 and 5, 6. Now there is a possibility that 5 appears in both the dice, right? The question is it appears in at least one. So it can appear in both. So let's include that one also. That makes it as 5, 5. That's only one outcome. It's not 2. So 5 outcomes where it appears in the second die. 5 outcomes where it appears in the first die. 5, 5 is an outcome where it appears in both the dice. 5 plus 5 plus 1, 11 outcomes are basically our favorable outcomes. So the probability of getting at least one 5 is essentially the number of at least one, let me write it, it doesn't appear as a 15. At least one 5 is a number of favorable outcomes, which is 11 divided by the total number of outcomes, which is equal to a 36. This is method 1, where we listed it down, found it, doesn't take too much time, a very elegant way to get to the answer, no problem at all, it's intuitive, you'll get the answer. Let's do it a little differently, right, just to say that there is an alternative method that's existing, right. Now, what is the opposite of getting at least one 5? You're rolling 2 dice, you need to see at least one 5. You can have a 5 in the first die or in the second die or in both. The opposite of that is not getting 5 in any of the dice, right. So the opposite complement event for us the complement is not getting 5 even once, which means the first die is going to show us a number which is not a 5. The second die will also show us a number which is not a 5, right? The number of outcomes possible when a die is rolled once is 6. The number of favorable outcomes, you are going to get a number which is other than 5, which is 1, 2, 3, 4 and 6. There are 5 possibilities where you will get a number other than 5. So, 5/6 is the probability that the first die will show a number which is not a 5. Similarly, 5/6 is the probability that the second die will also show a number which is not a 5. So, the probability that both dice show a number which is not a 5 is 5/6 times 5/6, which is equal to 25/36. This is the probability of the complement, right? The event of not getting even a single 5. So, the probability of getting at least one 5, this is equal to 1 minus the probability of not even one 5. The probability of not even one 5 is 25/36. So, 1 minus 25/36 is the answer. 36 is the common denominator. 36 minus 25 is what we are left with, which is 11 upon 36. Is this the same answer we got with the first method? Yes, by listing down we got the same 11/36. Here again we got 11/36. So, two different ways to arrive at the same answer. Choice B is the correct answer to this question.
Before you leave, I want you to do two things. One, sign up at online.maxtute.com to get started with CBSE Class 10 Math online tuitions. It takes all of 5 minutes and less than 3 steps to get started. And second thing, I want you to subscribe to this channel and turn on notifications so that you get notified every time a new video is uploaded. Spread the word about this channel to your friends and classmates.